Welcome back. In this video, I'm going to discuss the load and resistance factor design method of designing a reinforced concrete circular column with axial and biaxial bending load based on eStructural Design Tao found on the App Store. Get the factored axial load from the axial dead load and axial live load. Get the factored moment from moment dead load and moment live load for axial bending load, and moments of both axes for biaxial bending load. Then solve its corresponding eccentricities. Enumerate input parameters required. Name of column like C1, C2. Floor designation like ground to second. Shapes and ties. Diameter of column. Unsupported height. Bar configuration with number of bars. Vertical bars with size and grade. Steel ratio. Spiral tie bars with size and grade. Strength of concrete, and design loads. Solve the factored axial load and factored moment of single or both axes and its corresponding eccentricities for axial or biaxial bending loads. From the number of bars, get the area of steel. Then solve the gross area of section to get the ratio of steel reinforcement, which should fall between 1% to 8%. Then get the spacing between bars and check clear spacing between bars. Assume a value of neutral axis C that will correspond to the given eccentricity. Identify each bar distance from neutral axis and its force type. Get the steel stresses of each bar with corresponding force type, which should not exceed Fy. From the steel stresses, get the forces of each bar by multiplying the area of steel bars from the stresses. Solve the force of the compression block to get the actual nominal load from all the forces. Perform final check for eccentricity, then solve the actual moment. To check for adequacy, the design axial load should be less than the actual axial load, and the design moment should be less than the actual moment. Follow the computations for spiral tie bars. Design recommendation format as follows: design criteria, column size, vertical bars, and spiral tie bars. Thank you for watching. If you find this new lecture series helpful, please like, share, and subscribe to this channel.